Hello students, in today's lecture we are going to discuss uniform circular motion and non-uniform circular motion. Circular motion, that is the motion of an object along the circumference of a circle, but when it is uniform and non-uniform. If during circular motion, suppose this is the particle which is performing the circular motion along this circular track in an anti-clockwise direction. If the speed of this particle remains constant, then we can say that the motion is uniform one. That is uniform circular motion. The particle is performing circular motion, but its speed remains constant, and therefore we can say that it is the uniform one. So uniform circular motion, during the circular motion, if the speed of the particle remains constant, then that is called the uniform circular motion. Okay. In uniform circular motion, what is the direction of velocity? Suppose the particle is at this position at a particular instant. Then this tangent that gives the direction of linear velocity. So tangential path to the circular track at every instant, that gives the direction of linear velocity. In uniform circular motion, the magnitude of linear velocity does not changes, but the direction of this linear velocity always changes. It changes at every instant by keeping the magnitude constant, and it kept magnitude constant, therefore we can say that it is the uniform one. Okay. Then what is the factor which is responsible for the uniform circular motion? That is the acceleration. In this case, in uniform circular motion, the acceleration, it is along the radius and towards this circle, and therefore that acceleration, it is called the radial or the centripetal acceleration. So this is very necessary factor, centripetal or the radial acceleration, due to which the particle is moving along the circumference of that circle, that is performing the circular motion, and the velocity, the magnitude of velocity, that is also constant. Therefore it is a uniform circular motion, and this acceleration, it is along the radius and towards the center, therefore it is called the centripetal acceleration. So for uniform circular motion, the two things are very important, that is the acceleration, and second thing, the direction of, that is the velocity. If the acceleration, it is along the radius, or we can say that the centripetal acceleration, and if the velocity is tangential, then the particle can perform the circular motion, and if the magnitude of velocity remains constant, then it is the uniform circular motion. Okay. So acceleration, what is the magnitude of acceleration in case of uniform circular motion? Magnitude, we can determine the magnitude by using this relation, that is radial acceleration magnitude, it is equals to, that is r omega square. This is the magnitude of, that is the centripetal acceleration in case of uniform circular motion. So this is the magnitude. Okay. And what is the non-uniform circular motion? In case of non-uniform circular motion, if the velocity or linear velocity, or if the speed of the particle goes on changing, then we can say that it is the non-uniform. Suppose this is the particle which is performing the circular motion with changing velocity, magnitude of velocity that goes on changing, then we can say that it is the non-uniform circular motion. Okay. In case of uniform circular motion, the magnitude of radial acceleration, that remains constant. Centripetal acceleration or radial acceleration in UCM, uniform circular motion, that always remains constant. because magnitude of velocity constant. But in case of non-uniform circular motion, the magnitude of radial acceleration does not remain constant. Otherwise, the acceleration in case of non-uniform circular motion, due to the changing velocity, the acceleration, it is along the tangent of this velocity. When the velocity increases, then it is along the direction with velocity, and when the velocity decreases, then it is also along the direction of velocity, but it is in the opposite direction. So that acceleration which is along the tangential path or along the direction of velocity, that is called the tangential acceleration. So in case of non-uniform circular motion, the acceleration is tangential. So when the velocity increases, it is along the direction of velocity, and when the velocity decreases, then it is opposite to the direction of velocity. Sometimes it is along this direction when the velocity increases, and sometimes it is along the direction of velocity, but it is in the opposite direction. So due to that, there is a changing velocity, there is a change in acceleration, and therefore such kind of motion is said to be the non-uniform circular motion. Then what about the angular velocity? What is the direction of angular velocity? What is the direction of angular acceleration? So in uniform circular motion, the direction of angular acceleration, it is always along the axis of rotation. But in case of non-uniform circular motion, again the angular acceleration, the direction of angular acceleration, it is along the axis, but sometimes it is along the axis. That means if it is the axis of rotation and the particle is moving in this direction, that is in anti-clockwise direction, then what is the direction of angular acceleration? Then we can determine the direction of angular acceleration by using a right hand thumb rule, like this. Particles are moving in this direction, then this thumb, outstretched thumb, that gives the direction of angular acceleration. So it is in this direction. But when the velocity decreases, in case of non-uniform circular motion, velocity goes on changing. Sometimes it may be increases, or sometimes it may be decreases. So when it increases in this direction, then this is the direction of angular acceleration. And when it decreases, then again angular acceleration, it is along the axis, but it is in the downward direction. So this is the angular acceleration. Okay. So in uniform circular motion and in non-uniform circular motion, we have to consider these factors. And one more important factor, when we are considering the particle is performing non-uniform circular motion, if the particle changes its velocity, can it changes the plane while changing the velocity? No. In case of non-uniform circular motion, the direction of velocity, it is along the tangential path. The magnitude of velocity goes on changing, and when the magnitude of velocity goes on changing, the particle does not change the plane. The particle moving in the same plane. Okay, so we have to remember this factor, that is, while changing the velocity, in case of non-uniform circular motion, particle do not change the plane. Okay, so this is for uniform circular motion and the non-uniform circular motion. Thank you.